Now we have understood the concept of electric dipole and we have calculated the electric field due to this dipole. So let us first go to this example 1.10 to understand the concept better. So there are two charges. One charge is negative 10 microcoulomb, another charge is positive. So plus minus 10 microcoulomb, and they are placed 0.5 millimeter apart. So the distance between them is 5 millimeter. Please remember the distance is 5 millimeter apart. Determine the electric field at point P. So in first case, electric field is at point P. Both the charges are separated by a distance of 5 millimeter. So we have to calculate this electric field P on the axis of dipole. In first case, 15 centimeter away. So this distance is 15 centimeter. Please remember the units of this. This is 15 centimeter and dipoles are 5 millimeter apart from its center O on the side of positive. So this is the thing. Now as shown in figure 1.21a, this is first figure. Now and B, in case B at a point Q. In second one we have to measure at point Q. This Q is 15 centimeter. This is again 15 centimeter. Please remember the unit. This is 15 centimeter away from O on a line passing through O and normal to the axis of dipole. So as you saw, this is becoming the first case where the point lies on this axis itself. In the second case, this is the second case where the point falls on a plane, equatorial plane. If we draw an equatorial plane, this point falls on this equatorial plane. Now we have to solve the electric field due to these dipole due to on these points P and Q. So this is the application part of what we have just saw. Now let us solve this at point P due to charge. So this is the first case. Due to first case, positive charge. So remember, this was negative, this was positive, and this is the point P. The distance was 15 centimeter and the distance between them was 5 millimeter. And this is the midpoint. The midpoint is 2.5 millimeter from negative side and 2.5 millimeter from positive side. Okay, so this is the whole diagram. So now at point P, due to positive 10 microcoulomb, so from positive, so 10 microcoulomb, we simply say write 10 into 10 to power minus 6, that means 10 to power minus 5 coulomb, that is 10 microcoulomb. So this is the charge, this is the constant 1 upon 4 pi, this is the value of epsilon naught. Now we have to take the distance. What is distance? So distance is 15 minus this extra. This is from center, so we have to minus this distance for positive charge. So this is 15 minus 0.25. Why? Instead of 2.5 we put 0.25 because whole thing is now in centimeter. And square of this now converting centimeter to meter. So 1 centimeter is equal to 10 to power minus 2 meter. When we square this, so there comes 10 to power minus 4 at square. So this is 10 to power minus 4. We have converted everything into meter. So this is the whole story. This is for this positive charge. Now for a negative charge, similarly, this is 10 microcoulomb, this is 4 pi, this is again epsilon naught, this is 1 upon distance, but this time distance is in positive. So 15 plus 0.25 square, and again changing in meter, 10 to power minus 4. So we saw, and last one was 4.13 when solved. This is 4.13 into 10 to power 6. This time this is 3.86 into 10 to the power 6. So we saw there is a slight difference, as we always saw that say that there is a slight difference, little bit difference, and because of little bit difference, this is 4.1, both are in 10 to power 6, but this is 4.13, this is 3.86. Because of this small difference, there is an electric field, not zero electric field at the point P due to a dipole, because charges are not exactly at the same place, but there is a small distance between them. So now what is the resultant? For positive charge there is one direction, for negative charge there is another direction. So if we see in this figure, so for positive charge the electric field is in this direction, for negative charge the electric field is in this direction, and we see that the field due to positive charge is much more because the distance is less. So let us calculate this. So the total field is 4.13 into 10 to power minus 6, 10 to power 6 minus, this is 3.86 into 10 to power 6. So 10 to power 6 is common, and when we calculate this is 0.27. That means 2.7 into 10 to power 5, okay, Newton per Coulomb. So this is the total field, which is given here. So here it is given. What is the direction? It's along BP. So BP, so this is B and P. So total electric field is in this direction. Why? Because field due to B was more, field due to A was less. So net direction is along this BP. Now let us solve this second case. Please remember the figure. This is point Q, A, B. Small distance between them is 5 millimeter. Half distance is 2.5 millimeter. This distance is 15 centimeter. This is direction due to B. This is direction due to A. This direction is due to A. This direction is due to B. And net direction is this. And here we can see that dipole direction is this, and this is opposite to the direction of dipole. So there must be a negative sign. And as you see, this is again not an equilateral triangle, so we have to measure the cos theta. So cos theta in this case, let us calculate cos theta. Cos theta is simply this distance, which is 2.5 and under root 15. This is 15. So this is 15 plus 0.25, 15 square plus 0.25 square. So this is in 2.5 millimeters, so that means 0.25 centimeter. Let make this thing consistent. So this is the cos theta, 0.25 upon 15 square plus 0.25 square. So this is the theta. So we have calculated a theta. Now let us go back to this. So in the first case we got an electric field 2.7 into 10 to power 5 Newton per Coulomb. So this is when we separated these things out, when we calculated individually, then added. Here R was 15, the distance was 15, and the distance between dipoles was 5 millimeter. And if we calculate this R by A, so this was quite large, 15 upon 0.25, and this comes as 60. 60 is quite large, so this is large. R is greater than A, so we can use the formula what we calculated for this dipole at large distances. For large distances, E was 2p 1 by 4 pi epsilon naught R cube. So this is valid for R greater than A. So when we put this, so P is 2qa, so simply 2a, this is 2a into q, so this comes as P. Then 4 pi epsilon naught remains the same, and the distance, the total distance R was 15 into 10 to power minus 2 and cube of that. So this also comes as 2.6 into 10 to power 5, which is almost the same. So hence this formula is valid when R is greater than A.